Okay, good evening everyone, and thanks for watching our first video on Chapter 8 in your textbook. We'll be working on page 294, looking at the examples, going over each and talking about methods to isolate the variable. So what we're really working on here in Chapter 8 is algebraic equations, where we have to find the value of the variable. And in the first example, what it gives us is 2x equals 3/4. That's our first equation. It asks us to solve for x. Now this is slightly unique from your grade 7 and 8 experience with algebra in that you have fractions involved in your equation. Well, for the good news is for this one it's not that hard because what you really have here is a coefficient of 2. And what you know about coefficients is that they're multipliers, and in order to isolate the variable or to get the x by itself, we have to use opposite operations. And if you look at the 2 that's with the x, you understand that multiplication of 2. So in order to get rid of multiplication by 2, I'm going to divide both sides by 2. So I'm going to show divide by 2 and divide by 2. And I'm going to show it like this instead of, usually I would put the divide by 2. Actually, usually what I would do is take the line and go divide by, oh, that's not what I wanted to do. I'd say divide by 2, and then I go divide by 2. But the problem is, obviously here, that looks very confusing. So because we're dealing with fractions, I'm going to put divide by 2 here, and I'm going to show that multiplying by 2 and dividing by 2 are canceling properties. I'm left with x. And over here, what I really end up with is a division of fractions. Now that takes us back to grade 8 when we worked with division of fractions. I said, well, what is 3/4 divided by 2? Well, 2 is really 2 over 1. And when I divide fractions, I know I have to change it to multiplication and use the reciprocal of the second fraction. So it was 2 over 1. It's now 1 over 2. So in order for me to figure out what 3/4 divided by 2 is, I really need to do 3/4 multiplied by a half, which is the reciprocal of 2. And then I just multiply the tops. 3 times 1, 4 times 2. I get 3 over 8. So my answer is x is equal to 3/8. Okay? And if I wanted to check that out, I could go back into my equation. It says 2x equals 3/4. Okay, and it says substitute. So 2 over 1 times 3/8, which is the value of x that I said it was, should equal 3/4. So I have 6 over 8, right? Multiply the tops, multiply the bottoms, which reduces down to 3 over 4. Yeah, so it does equal 3 over 4. So the value of x is 3/8. That was A. Let's look at B. B says m over 3 equals -2/5. Notice how I changed the location of the negative symbol for the fraction. It looked like this in the book. I like to keep it in the numerator because when I start working it, it's just nice to have it in a central location, and it's best. So if you get in the habit of putting your negative symbol in the numerator of negative fractions, life will be good. Now, there's a number of ways we can do this. The first way is to realize that this is exactly the same question as the last one, except instead of having a numerical coefficient, we have a fractional coefficient. So m divided by 3 is really a third of m, or 0.3 repeating m. If I see it like that, it's kind of a different way to look at it, but some of us like to look at it like that, some of us don't. But generally what I want you to be able to see here is that that's a third of m, or I'm taking m and I'm dividing it into 3 parts. And we know from our algebra sense that if I multiply it by 3, dividing by 3 and multiplying by 3 will give me just my m, okay? And then what I want to do is I want to say, okay, I'm multiplying this side by 3, so now I have to multiply the other side by 3. And again, since we're dealing with fractions, I'm not going to show 3 as just a whole number. I'm going to show 3 as being 3 over 1, or 3 wholes. That helps me kind of visualize how I solve this. So now I have -2/5 times 3, or 3 over 1. Multiply the top, so I get -2 times 3. 5 times 1. I get -6 over 5. Okay? Now that could be sufficient for an answer, or because it's improper, you can change it to -1 and 1/5. That's the answer as well. So if we're dealing with fractions, we can say it's -1 and 1/5, or if you're really, cool, you can say, well, hold on, I know that 1/5 is 2/10, so it's -1 and 2/10. I can change it to a decimal because I'm brilliant. Well, you're brilliant, not me. I'm just a teacher. But that's one way to do it. Now there is another way to do it, and it's the second method, and I want to show it to you, and it's going to play a pivotal role, not so much in this chapter, but in the next chapter for sure. So what I have here is I have, if I was to draw it, I have a third, this is m, so I have a third of m. There's m, and I have a third of it. So I have a third of m equals 2/5. I don't even have, normally we would show 1 like this, but I don't have one of those. I'm going to use a bigger circle to show you 2/5. So I have 2/5 of it. So I think that looks like a star, doesn't it? Asterisk, yeah. So 1, 2/5. So that's my enlarged version of my negative 2/5. All right. So what I have to do here is, if I tripled this, right? If I tripled this, I would have a full m. But if I tripled this amount, I'd still have a fraction. So what I want to really realize is that if I multiply both sides by a factor that is common to both denominators, in this case 3 and 5, if I multiply by, let's say 15, and multiply by 15, okay? What ends up happening is I'm going to have 15 of these. And I don't know if I could draw it. But if I have 15 of these, right here, 15 of these bad boys here, what I end up having, and I'm going to cross reduce here, 15 over 3 is really 5 over 1. I really end up having, if I have 15 thirds of m, I really end up having 5 full m's. Does that make sense? It's very hard to draw on this, but if I was to multiply this side here, m, a third of m, it's getting kind of messy. Let's go back up here a second. If I was to multiply a third of m by 15, I will end up with 5 full m's. I want you to contemplate that for a second. And if I multiply negative 2/5 by 15, you know, if I doubled it, I'd have negative 4/5. If I tripled it, I'd have negative 6/5. If I quadrupled it, I'd have negative 8/5. And if I had multiplied it by 15, I'd have really negative 30/5, which we all know is the same thing as just a full negative 6. So over here I'd have negative 5. Over here I'd have negative 6. So by taking this original equation, I got my eraser out here. If I take this original equation, m over 3, let me just erase all this stuff here. Negative m over 3 equals negative 2/5. And if I was to increase it 15 times over here and 15 times over here, I end up with this new equation. And what that allows me to do, it allows me to see a fractional equation, something that has fractional versions of a variable and fractional equivalency, and create a new equation which is 15 times larger on both sides, but because it's 15 times larger on both sides, it's now whole numbers. Okay? So now I would just take 5m equals negative 6, divide both sides by the coefficient because I have good algebra sense. I have m equals the same answer that we had before, negative 6/5, or negative 1 1/5, or like I said before, negative 1.2. All right, so let's try one of those right now. What I want you to do is take a piece of paper, and let's try one of those questions. All right, let's try m over 2 equals 5/8. Okay, so what I want you to do is try it first by saying, okay, I'm going to multiply both sides by 2. Try that method and see what happens. Then I want you to try multiply both sides by 8 and see what the difference is, okay? So press pause right now and give that a go and see what you end up with. Okay, you press pause and hopefully you've done it. So let's take a look at this. If I was to multiply both sides by 2, take my pen. Multiply both sides by 2. What you should realize is that in algebra, if you do one thing to one side of the equation and you do it the exact same thing to the other side, you keep this idea of equivalency, right? If you doubled the weight on one side and doubled the weight on another, you're still going to end up with equality. So m over 2 multiplied by 2, and I guess I'll just show it like this, multiplied by 2, is equal to 5 over 8 multiplied by 2. All right. So what happens over here? Well, over here we'd have multiply the tops, I get 2m. Multiply the bottoms, I get 2. So 2m's divided by 2 is really m. See how that works? So 2m, 1 times 2 is 2. So I have 2m divided by 2, or half of 2m's is just 1m. I'll put that over here. And then over here, 5/8, I end up with 10/8. So multiply the tops, and I multiply the bottoms. 10/8, which is really 1, and 2/8, which is really 1 1/4. So m equals 1 1/4, or since you are all brilliant people, you know that's 1.25. Okay, that's solving it using multiplying both sides by 2. But watch what happens when I decide I'm not going to double both sides. I'm going to multiply both sides by 8. I'll do it up here actually because there's more room. M over 2 equals 5 over 8. Now this time I'm not going to multiply it by 2. I'm going to multiply it by 8. So multiply by 8 over 1. Multiply by 8 over 1. Okay. Now if we look at this, we have multiply the tops, I get 8m. Multiply the bottoms, I get over 2. So 8m divided by 2 is really 4m. Okay. And over here I get 40 over 8, and 40 over 8 is really 5. So I get 40m, or 4m, excuse me, equals 5. That's by multiplying both sides by 8. And what I've achieved is I've created a new equation, an equivalent equation, but instead of being m over 2 equals 5 over 8, or fractions, I end up with a new equation that does not have fractions. It's beautiful. So divide both sides by the coefficient. I get m equals 5 over 4, or 1 1/4. See? I get the same answer, but instead of multiplying both sides by 2 to isolate the variable, I decided to multiply both sides by 8 to create a new equation that doesn't have fractions. Okay. Let's try the last one here. We're getting a little, 11:35. This is my longest video ever. All right, the last question C says negative 2 1/2 k equals negative 3 1/2. Well, the only difference between this question and the last question is that we have mixed fractions. And really, if I wanted to look at this in decimal form and make it less complicated, you know, negative 2.5 k equals negative 3.5. You know, that's not a complicated one. I'd look at it and say, well, I know what to do here. I'd just divide both sides by negative 2.5 and I get my answer. Right? This one here I'd probably need a calculator for, but that's how I do it. Well, the same thing happens, except I'm going to divide both sides by negative 2.5. It's the same thing I would do there to get rid of the coefficient. I end up with k equals, but now I have to divide this side by negative 2.5. All right. So how do I divide mixed fractions? Well, it's the same thing as you divide regular fractions. The only difference is you want to look at them in improper form. So negative 7 over 2 divided by negative 5 over 2. You don't divide fractions, you change to the reciprocal. So negative 7 over 2 times the reciprocal. Keep the negative symbol up there. It works good. Negative 2 over 5, the reciprocal. Right? And I end up with negative 14 over 10, which is negative 1 4/10, or is negative 1.4. Wait, that's easy. That's all it is. That seemed really easy, didn't it? All right. Try one more on your own and see how you do. Here's the last one I want you to try. Try negative 1 1/4 x equals negative 0. Oh, no, I'm not going to do a decimal. Well, I could do a decimal, but I won't. Equals 1/2. Let's just make it that. Okay? So press pause on your video and then see the solution. Okay, welcome back. So the first thing you probably did is you said, okay, I'm going to divide both sides by the coefficient. So negative 1 1/4. I'm going to divide both sides because x was being multiplied by that, and by dividing by the same number, I end up canceling those two processes, leaving me just with my variable. And over here, I have to think, okay, divide by negative 1 1/4. All right, so what does that look like? Well, 1/2, I'm going to change the multiplication. Actually, hold on. Before I change the multiplication, I want to think about that as division of its improper. 4 times 1 is 4, plus 1 is 5, negative 5 over 4. That's the same question. Now I look at it as its multiplication of its reciprocal. Right? I just changed the multiplication and flipped that fraction. I get negative 4 over 10. Is that right? Did I do that right? Yes, I did, didn't I? Yes, negative 4 over 10, which ends up being negative 4 over 10, or x equals negative 0.4. Okay? Hopefully that helps you with the first example. We're only done of example 1, and that was a 15-minute lesson. I'm hoping that helps you. and check out the second video on example 2.